Hello, you're welcome back. All right, so we're going to be looking at sequence and series in this video. Okay, so the question is, what's sequence, right? Okay, now sequence of numbers. Okay, the sequence of numbers are numbers that is arranged. Of course, numbers are numbers arranged in an order. Okay, in an order by a specific rule. Okay, so there's a specific rule of arrangement. For example, if we see such number, okay, we have 2 comma 4 comma 6 comma 8. Okay, so I believe that you can actually discover the rules of this arrangement. All right, that will actually enable you to get the next term. So of course the next term is 10. This is a typical example of a sequence. All right, so there's a rule for the arrangement. So for this sequence here, I have each term, each number, okay, is actually gotten by adding 2 to the previous number, right? So I add 2 to this 2, I have 4. I add 2 to 4, I have 6. I add 2 to 6, I'll have 8. And I add 2 to 8, I'll have 10. Okay, all right, so now we are going to be looking at different types of sequence. And of course, sequence is also known as progression. Okay, so we're going to be looking at, we study different types of sequence. There are many types, but we are going to just study two. All right, so we are going to study arithmetic sequence or progression. Arithmetic sequence. Arithmetic progression. Okay, by abbreviation, we call that AP. Okay, arithmetic progression. Then, after which we now study geometric progression. Okay, so by abbreviation, that's GP. Okay, so starting with the very first, okay, which of course is the arithmetic progression AP. Now, AP is an arithmetic progression or is a sequence, okay, in which two consecutive um, terms actually have what is known as a common ratio. Common difference, please pardon me. Two consecutive terms in that particular sequence, all right, will always differ. They differ by a common difference. And we use the same with D to represent common difference. Now look at what okay, the sequence I gave you previously is an arithmetic sequence. All right, example 2 comma 4 comma 6 comma 8. This is arithmetic sequence. Why do I call it arithmetic? Okay, two consecutive terms. That is the let's say this is the first term and this is the second term. Okay, so the difference between this first and second term is 2 because 4 minus 2 is 2. Okay, the same with this 6 and 4. 6 minus 4 is 2. 8 minus 4 is 6. So that's a common difference between two consecutive terms. All right, so that simply means that for this is an AP because I have a common difference, which of course is equal to common difference this given as 4 minus 2, which is 2. All right, 4 minus 2, which is also equal to 6 minus 4, which is also equal to 8 minus 6, and that is 2. So the common difference of this particular progression is 2. So because I know the common difference, I'll be able to predict or to get the next term. Okay, the next term is 10, the next is 12. All right. So that means I can get a number of them. But you discover that if I'm being asked to find, let's say you are being asked to get the 100th term. Okay, you are being asked to get the 100th term. Now, the 100th term of this particular sequence, if I should go by adding 2 to the previous term till I get to the 100th term, you discover that that is not ideal. Okay, that will be it's going to be very ambiguous method of solution, and that is not ideal at all. So how do I actually find any number of term of a sequence without having to go through, okay, adding common difference to the previous term till I get to that particular number of terms? So that's I'm gonna introduce a formula. Okay, now this is the formula of the nth term of a sequence of an AP, nth term of an AP. So it is this formula of the nth term of an AP that will enable us find any number of terms, okay, directly without going through this ambiguous process of adding the common difference to the previous term. So the formula goes this way. The nth term of an AP is equal to A plus n minus 1, then multiply by D. Okay? This can enable me find any number of terms. Okay, for example, now let's confirm that this formula works. But before then, let's okay write down the parameters. Okay, the Tn is actually the nth term, the value of the nth term that you're looking for. The A here represents the very first term, the first term of the AP. Okay, okay. For example, this AP, the first term of this AP here is 2. All right, the N is the number of term. Okay, the number of term. So that number of term that you have to evaluate. Why the D? Of course, you know what the D is. The D is the common difference. All right, this is the common difference. So let's actually test this to see whether it works. Okay, let's prove that this 1, 2, 3, 4, 5, 6. Let's prove that the system of this AP is equal to 12 by using this formula directly. Okay, so let's solve that. So I'm looking for the system T6. So I call it T6. So T6Tn. Now the very first term of from the formula, okay, the n term is given as first term plus n minus 1 all multiplied by d. Okay, so let's go check for the first term. The first term is 2. So I put 2 here. Then plus bracket open. The n is the number of time I'm looking for. The number of time I'm looking for is the system. 1, 2, 3, 4, 5, 6. That is the sixth term. Okay, so that's going to be equal to 6. Then, of course, minus 1. Bracket closed. Then multiply by the common difference. Okay, so what is the common difference? The common difference is 2. The common difference of this sequence is 2. So I multiply by 2. So let's do that. This is going to be 2. 6 minus 1 is 5, right? So I'm going to have 2 plus 5 then times 2, which of course is going to be 2 plus 10, which now gives 12. So that has been confirmed. Okay, so the system is 12. So that shows that you can use this particular formula to get any number of terms. Okay, you can get the 100 term, you can get the 200 terms. So it is much easier. Okay, so I hope that is well understood. Okay, now let's now proceed. Now remember we started with sequence and we also have series. Okay, now the question is, what series? Series is simply the sum of sequence. All right, the sum of sequence. So when the sequence is being summed, so a sequence can be summed to any number of them. For example, if I have two, okay, um, 2, 4, 2 comma 4, comma 6, comma 8. If I use comma, it's a sequence. But if I replace this comma and introduce sum to it, okay, it becomes now a series. All right, it becomes a series. So the sum of a sequence is series. Now you can sum sequence to any number of them. All right, like the sequence I had before probably was two, okay, was 2, 4, 6, 8, 10, 12. Okay, now I actually went and created a series out of it, and that series I only summed the sequence up to the 1, 2, 3, 4, 5. Okay, up to the 5 terms. So the sum of this sequence, the sum of the first 5 terms of this sequence, 1, 2, 3, 4. Okay, that's 4. Or the sum of the first 4 terms, please pardon me. The first 4 terms of the sequence is what I have here. So now let's actually sum that. Now, if I should sum that, that's gonna be 6 plus 6. Yeah, that's 12. Okay, then 12 plus 8, that gives me 20. Okay, so that is summing a sequence. Series is the sum of sequence. But you discover that for this AP, all right, because I'm dealing with AP now. Okay, for this AP, if I'm being asked to find the sum of 100 terms, okay, I can still go through the process of listing out the from number 1 term to from the first term to the 100th term, then another sum. It's not going to be ideal. Okay, it will be so ambiguous. So that is what now led us to another formula, all right, known as the formula for the sum of nth term, sum of nth term of an AP. So with this formula, I can find any number of sum. Okay, I can sum the AP to any number, any value. I can sum it to the first 20 term, first 50 term, any number. So it is much easier than going through this process. All right. So what's the formula for the sum of the nth term of an AP? Simple. Now the formula is Sn. Sum of the nth term, okay, is equal to n all over 2, bracket open, 2a plus another bracket opens here, n minus 1 multiplied by d, then bracket closes. All right, now all this formula, right, though they have derivation, I don't want to go through the process of their derivation. I've given you one. Now let me call this formula number 2. This is the formula for the sum of the nth term of a GP, okay? Because I'm interested in solving question with this formula, right? So just in case you'll be asked to find the sum of the nth term of a GP, you use the formula, okay, directly. Now let's actually test this formula, right? To see whether my formula is correct. Let's evaluate this. The sum of the very first fourth term of this AP. All right, let's get to evaluate that using this formula. So I want to find S4 using this formula. So the n is the sum of the very first four terms. So the n is 4. That's 4 all over 2, open bracket, 2 times the first term. The first term is 2, then plus 4 minus 1, then multiply by the common difference, which is 2. Okay, so let's evaluate that. Okay, of course, 4 can divide 2 to give me 2. Then I have bracket open. 2 times 2 is 4. All right. Then, of course, 4 minus 1 is 3. 3 times 2 is 6. So, if I should do this now, 4 plus 6 is 10. So, I'm going to have 2 times 10. Okay, which of course is 20. So, which confirms that this formula is valid, okay, for finding the sum of the nth term of a GP. So, please take note of them. Okay, so first we need to actually go through the formula, then we'll now solve a complex examination question. Okay, so take note of it. So basically, that is exactly what I want to show you in GP. All right, and AP, please pardon me. But we'll go to before we get to GP now. This is another way of expressing the sum of the nth term of uh, an AP. Okay, can also be expressed in the following way. We already know that. Okay. Now I'm going to this. Here I have 2a, so I'm going to split it into a plus a. Okay, then of course I have n minus 1, then multiply by d. So of course this a plus n minus 1, you know this is the nth term of that particular sequence. Okay, now since we are dealing with sum, okay, so that means we are dealing with series. For example, in this case now, it's the sum of this series. This is the series I'm actually working on. The series S4, which of course is gonna be the sum of the sum of 2 plus 4 plus 6 plus 8. So discover that 8 now is the last term of that particular of the series. So 8 here is the last term. And you know very well that 8 is also can be found using the nth term formula. All right. So now this formula here is the nth term formula, and that is the last term, because if you are summing, you sum all the way from the first term to the last term. All right. So that means this formula now being the formula of the nth term, okay, of an AP becomes the last term, okay, of that series that you are summing or the sequence, okay. So invariably now this is another way of expressing this, since we already know that the last term, okay, of a series is equal a is going to be equal to a plus n minus 1, okay, then multiply by d. So I can simply say that Sn is going to be equal to n all over 2, okay, bracket open, a, then plus the last term, okay. So this is another way of expressing, that's another way of expressing the sum of the nth term of an AP. All right. So please take note of that. So this can actually help you. Let's say a situation where, okay, you are being given that the sum of the nth term of an AP is equal to 20, and the last term is 8th. Okay, and the last term is 8. So please pardon me. We are told that the sum of the first four term of an AP is 20, and the last term is 8th. Okay, so the question now is find the first term of that particular AP. You apply the formula. So x4, the formula you're going to apply is this formula, all right? So by this formula, x4 is 20. That's going to be 20 equal to, of course, n is 4. That's 4 over 2. Bracket open. We are looking for a. That's the unknown. And we are being told that the last term is 8. Okay? So if that being the case, 2 divided by 4 is 2. So I'm having 20 equal to 2. All right? A plus 8. This is going to be 20. Open the bracket. 2 times a is 2a. Then plus 2 times 8. That gives me 16. All right? 2a now is going to be equal to, of course, 20 minus 16. Which, of course, you know is that is 4, right? So a now is going to be equal to 4 all over 2, which is equal to 2. As simple as that. Okay, so please take note of all this formula. They are really very important. Okay, so we are going to look at GP, and that will be in the next video. All right, see you in the next video. Thank you very much.